feel free to ask questions as they come to you. You don't have to wait for the end. We'll have several people responding to those questions as we move along. So feel free to do that. So on this graph, you see the three primary types of interface that we're using and a variety of the outputs that they provide to us. At the top of the clock, where the eye is the eye tracker. And an example of that is shown just to the left of the eye. There's a document that's showing where the person is looking while they're reading. The larger the pink dot is, the longer they've looked at a word. We've seen some very interesting results here where when someone looks at a word like the word you in a sentence, we see other needles bouncing on our system, needles that relate to their emotional response to just the identity of the word you with themselves. We also have seen that when they reach a word that is hard to pronounce, that their frustration level rises. Now, moving on the clock to the right, in the 1 o'clock, 2 o'clock position, the facial muscles are picked up by the headset and are transmitted directly to avatars, for example. So in the future, Second Life avatars will be able to smile when you smile rather than when you click a button to say, to tell it to smile. It'll simply respond to the way you're actually feeling and looking. So facial muscles are picked up automatically and do not need training across cultures because all of us around the world smile the same way, frown the same way, wink the same way. All the facial muscles operate in the same ways. Just below that on the right-hand side are some of the emotional clusters that are tracked. We're going to go into a little bit more detail on this in just a few minutes. But basically, we can see lines that tell us when the person is interested, when they're agreeing with the content, when they're concentrating on the content, when they disagree with the content, when they're thinking about it, when they're unsure, and things like that. Now, in the 6 o'clock position at the bottom is a skin conductance representation. This, in the past, was the only form of biofeedback we had, and it gave a very broad piece of feedback that was primarily related to arousal. We could only say whether the person was generally aroused by the information or not. So, but now we can add a lot more specific information to that. Moving up now into the 9 o'clock position, the leads on the headset, and one of our colleagues actually at the table with us tonight has the headset on. We hope in a future demonstration to be actually able to show you the avatar as it's responding to the user who has the headset on. You can see in the skull display to the left of the 9 o'clock position where the green dots are, it's showing where most of the leads position themselves on the head. There's actually 16 leads, and these are a subset of the traditional EEG. They are telling us and picking up information from the same parts of the brain that a regular EEG does, but with far fewer leads and with much less trouble to the user. Because the headset is wireless, we can put users in even learning groups together with or without digital experiences and learn what the relationships are between the emotions and the EEG signals and types of tasks that are involved. Just above that is the streaming information that comes off of the EEG, and that's a part of what our analysis is all about, is looking at this complex, noisy data that takes place over time. Continuing now with the anatomy of this system, we gather about 125 frames per second on the average for all of the different forms of data. This gives us a lot of different kinds of output and, of course, a lot of data per second. And we are able to report on engagement, boredom, excitement, frustration, meditation, all through the wireless emotive headset. The brain hemispheres that were recorded on that last slide, by the way, also give us clues as to the cognitive involvement at that period of time. So, for example, if a person is using a lot of decision-making, we expect to see frontal lobe. if they're using a lot of their visual representation and visual problem solving, we expect to see parietal lobe at the back. So we look for expected values in these to figure out what's going on. The data is giving us new forms of information about the attention and the direction and the time of focus while a person is doing something on a computer. So this is now a brand new and very enriched set of data that we're learning how to use. We get a video stream at the same time so that it helps us do what's called external validation. If we only had the model of what the learner was thinking, we wouldn't know exactly at what point in time something happened. But because of the ability of digital materials, we're now able to also externally validate the moment within a problem-solving period of time when someone is experiencing a particular emotion. We're going to see this in examples that are coming up where we have used eye tracker and the headset combined together while doing Guitar Hero, which is one of our experimental platforms at the present time. The Tobii eye tracker at the bottom of this page is the hardware-software package that we use for that, and you'll see a slide in a couple of minutes that brings a lot of these pieces together.